The same mechanics of control, the same graphic representations apply when the dependent variable is summarized by means. It's a comfort to know that in many ways a mean comparison and control table is easier to interpret than cross tabulations. This just seems like a general principle of analysis. When you condense numbers, when you condense a relationship down to a single mean value, it's easy to interpret this measure of central tendency. Now let's look first at an additive relationship, a set of additive relationships here. And it's another gender gap hypothesis. Here's the basic hypothesis. In a comparison of individuals, women will hold more positive feelings toward gays than will men. So in this hypothesis, the independent variable X is gender, and the feeling thermometer rating of gays is the dependent variable. I believe the feeling thermometers have come up before, but let me just review. The American National Election Study asks about political personalities, candidates, groups, and asks respondents to rate these political objects on a scale ranging from 0, that is, a respondent would feel very cold and negative toward that group, to 100, which it would be a very warm and positive feeling. So we're going to look at mean values of the gay feeling thermometer scale, and we're going to compare how men rated gays versus how women did. That's the basic hypothesis. But let's control for age. I mean, there's a lot of evidence that suggests there is a big generational difference in how homosexuality and homosexuals are viewed in terms of generational cohorts. So we will control for age. Okay, now this is a mean comparison table that compares mean values of ratings of homosexuals by gender, controlling for age. Let's orient ourselves here a little bit, because mean comparison tables take a different format than cross tabulations. The independent variable, gender, is represented on the rows. So for example, we would compare this mean, this is the male mean, 17 to 39-year-olds, the youngest cohort. On average, these 992 males rated gays at 51 on the 0 to 100 scale. With this mean, 60.8, on average, the youngest cohort females rated gays at 60.8. So the comparison, the controlled comparison, the controlled effect, more specifically, would be to compare these two numbers. Move up to the next, the middle age cohort here. These two numbers, 47.5 versus 55. Then finally to the oldest cohort, 42.1 among the oldest males. That's the rating they gave gays on average, to 50.8. That's the mean rating that the oldest cohort females gave. So we assess the effect of the independent by reading down the columns. We would assess the controlled effect of the control variable here, age, by reading across columns. So for males, we would assess the effect of age by comparing 51 to 47.5 to 42.1, and we could make some determination about, over the full range of the control variable, what happens to mean values of the dependent variable. Is there an effect of gender among the youngest cohort? Well, yes. Among young males, a rating of 51, and then we go up here to 60.8. That is a difference, if you do that subtraction, that's a difference of 9.8 degrees on this 100-point scale. So that's something is going on, and our hypothesis appears to be supported in that the female mean is higher than the male mean. Let's go up here to the next age cohort. It's a little bit narrower here, 47.5 versus 55 among females, but again we're running in the same direction. That's about a 7.5 not percent, 7.5 degrees on the feeling thermometer scale, so there's still a difference. And then finally, among the oldest cohort, we have here 42.1 versus 50.8, which is an 8.7 effect. So just going back and asking the question, are these controlled effects about the same? I would suggest that they are. 9.8 among the youngest cohort, not quite as much in the middle, 7.5, but then 8.7. So one would argue that the effect of gender on feeling thermometer ratings of gays is about, 8 or 9. But you're not distorting reality to summarize into one partial effect. Similarly, if we compare the effective age among men, we can see that the thermometer here drops from 51 to 42.1. So age is doing some work here in explaining the dependent variable. That drop is at almost 9 points. That's 8.9 points. And we find a 10-point drop among women. So you might say the effective age is about 10. The controlled effects. Now again, these are not estimates. These are what we've calculated. The controlled effects of gender are quite similar across age groups. 9.8 degrees among the youngest, 7.5 for the middle cohort, and 8.7 among the oldest. So the partial effect, you could fairly condense these or summarize these numbers into a single number, and a good conservative estimate here, it strikes me, would be about 8. So yes, we got a single partial. The controlled effects of age is virtually the same. The controlled effective age is virtually the same for males and females. For men, scores decline 8.9 points across age groups from 51 to 42.1. And for women, the scores decline 10 points from 60.8 to 50.8. So we could summarize the effective age and say the partial effective age is about 10. So again, when it makes perfect sense to resolve controlled effects into single partial effects, then you're dealing with a happy circumstance of additive relationships. Here are the data graphed. Now, is life perfect here? No. The lines are not, as you would say, perfectly parallel, but they're very close in effect. You can see the effective age here is about 10, from the youngest to the oldest. And you can see along each line the effective gender is on the order of 8 degrees. So this is a profile of an additive relationship when you have a bivariate independent variable, male and female. But we have 3 values of the control variable, so it's a little more complex, but still it's essentially a pattern of additive relationships here. All right, let's look at a different example, and this would be an example of interaction using mean comparison analysis. This is from comparative politics. Let's say we hypothesize that the type of electoral system that a country has, that is, proportional representation or non-proportional representation, may affect the percentage of women in parliament. And we hypothesize that PR countries will have higher percentages of women legislators than will non-PR countries. So PR systems, as you probably know, encourage multiple parties, and one could further hypothesize these systems encourage more diversity within the party lists, and that women may be more likely to be elected to parliaments under PR systems. But here's an interesting wrinkle. It may be that the PR effect, as we can call it, may be conditioned by the cultural acceptance of women. So it may be that the effect of PR, non-PR on the percentage of female parliamentarians might be stronger in countries with higher cultural acceptance of women than in countries with low cultural acceptance. If the conditions are cultural conditions are not conducive for women in parliament, then it may be harder for institutional change to affect those outcomes. We'll see what we have here. Here we're looking at mean percentages of women in parliament by type of electoral system, controlling for cultural acceptance of women in leadership. So again, the independent variable non-PR, PR is on the rows, and we would compare, for example, on average, these 32 countries with low cultural acceptance of women, on average 12% of their lower house of parliament are female. And when you switch institutional systems here to PR systems, indeed, the percentage of female parliamentarians goes up by about 5 percentage points, from 12.0 to 17.0. Is there an effect in the hypothesized direction? There is indeed. So we would say, sure, there's something's going on there, even in countries with a low cultural acceptance of women. But let's switch on that amplifier again, if you will. And now we have these 21 countries in which there's high cultural acceptance of women in leadership positions. And let's first compare the effect of non-PR and PR. With non-PR, on average, 16.9% of these 11 countries, 16.9% of their makeup of their parliaments are women, but about 17 points. And that increases dramatically to 28 points, 28.3 points. So under conditions of high cultural acceptance, we go up about 11 points, 11 percentage point difference here, compared to about 5 percentage points here. So can we fairly summarize these two differences, 5 and 11, into a single partial effect? And the answer is no, that wouldn't be fair. That wouldn't be accurate. So we know we're dealing with a case of interaction. And as usual, here's that graph. Here's the effect. Here's that 5-point rise from non-PR to PR among countries with low cultural acceptance. And then that over 11-point increase among countries with high cultural acceptance of women.